Hey there, welcome back. Today we are going to solve few Java problems or Java puzzles using IntelliJ. And what we are going to do is we are going to download the project. So we are going to use a ready-made project which I have as a link in the description of this video. So I would request you all to download that project and open it in IntelliJ before proceeding to the next part. Once you open the project, you will notice that the project has two packages. So one package is where we write the code, and the other package is where the test cases will be written. So you don't need to touch the test cases, but instead you need to go to the package where we will write the source code. There is also some documentation about what problem we are going to solve, so you can read the problem also. And the solution we have to write will be in the form of a function. So we just have to write a function, and that will be our solution. So what are we waiting for? We should get started. But before getting started, I would also recommend, like, if you have not subscribed to this channel, you should subscribe for more such videos. On this channel, you will find videos on Spring Boot, Java, and IntelliJ. So hit subscribe and smash that like button. Let's get started now.
Hello guys, welcome back. So in this lecture, we are going to talk about a problem, and this problem is about reversing a number. And by the end of this lecture, you are going to have a complete understanding of this problems, how we went about solving this, and you will also be seeing an optimized solution. So let's get started. So let's start discussing the problem first. So I have this problem file open in front of me, and you can see there is some documented code over here. So let's go through the problem. So the problem is you are given an integer as an output. Now you are expected to write a program to return the reverse of the number, right? So you are given an integer as an input, and you have to return the reverse of that particular number. So how do you go about solving this? And you can see there are a couple of test cases that I have written over here. So you have return reverse. We are calling this function return reverse with 23 as the input, and you are seeing 32 as the output. So this is the expected output, complete reverse. 45, you get 54 as the output. So this is about the problem. Now let's see and let's try to think on how we can solve this particular problem. Of course, if you understood the problem, you can pause the video right now and you can attempt the solution yourself before even seeing how we can go and analyze the problem over here. All right. So we'll hop on to our presentation and we'll start thinking about this particular problem. So the first thing that we should know and we should understand is reverse is nothing but taking the last digit and putting it first. So obviously we all know this, but in programming terms, like if you have to identify a pattern, you should know that in order to get the reverse of a number, you need to take the last digit and put it first, and then take the next last, which is nothing but the second last right now, and put it after first. And you have to do this repeatedly till we reach the first digit, and the first digit then goes last. So this is nothing but how a reverse is created, a reverse of a string or a number. All right. So another thing that we should know over here is that the modulo operator that you see over here, so this is the modulo operator in Java, and with the help of this operator, if you use this operator and you divide any number by 10, you get the last digit of any given number. All right. So we know what is reverse now. How can you create a reverse? You take the last digit and put it first. You take the second last and put it first. And we also know that with the help of modulo operator, if you use modulo operator with 10, you can get the last digit of any given number. So these are the two cues in like which you can use to solve this particular problem. And there are two ways to solve this particular problem as I can see. So the first way is to get the last digit and append it to a string to form a reverse. So you can form a reverse by taking the last digit and appending it to a string, then take the second last append it to a string and form a reverse, right? This is one way. Another way is to use this particular formula here. So you can see this formula. So the formula is, so sum is equal to sum into 10 plus remainder. So this is the formula that you can use to form the reverse. So there are two ways in which you can solve the problem, and we are going to explore both the ways right now. But before that, I would request you all pause the video right now and attempt the solution yourself and see if you can try and solve this problem. All right, so welcome back. I hope you guys attempted the solution over here. So what I'm going to do is I'm going to start solving the problem with the help of the first way. So by using the first way, wherein we discussed that we can get the last digit and append it to a string to form the reverse. So we are going to try the solution, and we are going to write our solution in this function over here, where we have this start writing your code over here. So first I'll create a string over here, and since the string is changing, so we will be frequently changing the string and we would be appending the last digit, right? So hence I'll be using a string builder because you can change that. So I'll say string builder answer equal to new string builder. So we have created an object of string builder. Now I'll create a temporary variable over here, and I'll assign it the actual value that we are getting over here. All right. And I will also create a variable called remainder. Now what remainder will do is it will store the output after we use the modulo operator. So let me show you how. So what I'm going to do is I'm going to say while. So I'm going to use a while loop, and I'm going to say while n is greater than 0 over here. All right. And within this while loop, all the magic starts. So the first step would be to get the remainder. Okay. So like we discussed, how we can get the reverse. So you can get the last digit and you can put it first. And to get the last digit, we would be making use of the modulo operator, right? Along with 10 for you. So you can see we have the remainder now. So let's say if the number is 1, 2, 3, you will get 3 over here in the remainder variable. Now, what I'm going to do is I am going to say answer dot append remainder. I'm going to append the remainder onto the string builder that we created, right? So we have got the last digit. Now, after getting the last digit and appending it first, I need to remove that last digit from the main number. This is because if we don't remove the last digit, every time this loop is run, okay, this will be an infinite loop then, and every time we run this loop, we'll keep getting the last digit. So we need to remove that. Now, how do we remove that? So we'll make use of the division operator over here. And this is the operator that we are using. All right. And instead of returning 0 over here, I'll just change this to return sum. Sorry, not sum, but instead I'll return answer over here. So answer is currently in the string builder format, I'm sorry. And we need to return an integer over here. So I'm going to pass this. I'm going to make use of integer dot parse int, and this particular method accepts string as the parameter. So I'm going to say dot. So I think we have solved the problem over here. All right. Now I'll run the solution. Let's see what the output looks like. All a bit. So you can see we are getting pass for all our test cases, and we have successfully written the solution. So one thing that we can do over here is we didn't use this temp variable over here. So I can just remove this and I'll just run this. You can see the test cases are still succeeding, right? All right, so this is how you can attempt this particular solution, and we solved this particular problem by using the first way. So we got the last digit and appended it to a string to form a reverse. Now let's try out using this formula wherein we say sum is equal to sum into 10 plus remainder. All right, so what I'm going to do is I'm going to comment this code over here. And now I'm going to start writing the second way. So for the second way, I'm going to create remainder and a sum. So we need to store the sum. So I'm just creating a sum variable, and we need to store the remainder as well. And I'm going to create a while loop over here, and I'm going to again say while n is greater than 0, got full brackets over here, and here I'm again going to say remainder is equal to n modulo 10. So we got the last digit. All right, and we have the formula as sum is equal to sum into 10, and I'll say plus remainder. So this is the formula that we just saw over here. Sum is equal to sum into 10 plus remainder. Okay, we've used the same formula here. The formula used remainder, and hence we calculated the remainder first. Now over here, I need to remove the last digit, right? And I need to return sum. So let's run this and let's see whether the test cases pass. So you can see all the test cases are passing. So this is how you can solve this particular problem with the help of the formula. So I hope you guys have a clarity on how you could solve this particular problem and how you could think around a couple of ways in which you could solve this. So if you can find any other way in which you can solve this particular problem, I'm happy to hear. You can post this in the Q&A forum, and I would happy to review that solution. So that's about this class, guys. So in this lecture, we solved this particular problem of getting and finding the reverse of a particular number. So I hope you guys enjoyed this class and found this valuable. I shall see you guys soon. Thank you. Hello guys, welcome back. So in this lecture, we are going to talk about another problem. And I have this problem open here in front of me. Just click on this function. I'll go to view and say quick documentation. So when you do this, you will see the documentation that I've written over here coming in a pop-up formatted. You can either do it this way or you can read it from your choice. We'll talk about the problem. So the problem is to write a program to check if the number is a palindrome or not. And if the number is palindrome, you return true, else you return false. Now the question is, what is a palindrome number? So palindrome number is a number which reads the same forward and backward. For example, if you read 1 to 1, 1 to 1 is an example of a palindrome number. If you read it in a forward direction and backward direction, it's one and the same. The number 3 to 4 is not a palindrome number because the forward way is 3 to 4 and the backward way is 4 to 3. So they both are different. And hence this number 3 to 4 is not a palindrome number. So this is about the palindrome number, and you can see you have some test cases written over here. So we'll check the test cases here. So you can see you are evaluating it against 1 to 1, get true as the output. 223 is not palindrome, and hence you should get false as the output. And you have this input as 333, you get true as the output, and 987 is not a palindrome, so you get false as the output. And we would be writing a code over here in check palindrome function, which takes integer as the input, and it evaluates this integer and returns boolean true or false. So this is about the problem. Now let's talk about how we should think about this problem. So this is about the problem over here now. Now let's see how we can think about the solution. So if you want to attempt the solution right now, you can just pause the video and attempt it. So meanwhile, I'll just start talking about how we can think about the problem over here. So the first point that I would like to mention over here is to identify if a number is palindrome or not. You have to first get the reverse and then compare it with the original, obviously. So if you want to see if the number reads in a similar way in forward as well as the backward direction, you will have to get the forward version. So forward version is nothing but the number itself. And the backward version as well, which is nothing but its reverse. So you have to get the reverse as well as the original number, and you have to compare them both. And if they both are equal, you can say that it's a palindrome number. So this is point number one. Point number two is reverse. What is reverse? So reverse is nothing but taking the last digit and putting it first, then taking the next last digit and putting it after first. So this is how you get the reverse of any given number. So these are a couple of points that I would like to make over here before you start attempting the solution. Another thing that I would like to mention and you should know about is modulo operator. If you use modulo operator on any number along with 10, you can get the last digit of that number. So I think you have enough of hints now over here. So you know, like to identify the number as a palindrome, you have to compare the reverse and original. All right. Now reverse, what is reverse? How do you get reverse? So one hint over here is you can use the modulo operator along with 10 and you can get the last digit of any given number. And how do you get reverse? So to get reverse, you can take the last digit, put it first, second last digit, put it next, third last, put it next. And you have the reverse and the original number preserved. So what I would request right now is you all should pause this video and attempt the solution yourself. I think you have a couple of hints now. So you should attempt the solution and then you can play the video again to watch the solution that I give you. So pause the video right now and I'll see you soon. So welcome back. I hope you guys paused the video and attempted the solution. And let's now hop on to our coding editor. And here I'll try solving this solution myself. So what I'm going to do is we are going to start writing our code over here. All right. So if you run the code right now, you will see that it's failing. You can see failing. So we are just passing false by default. So few test cases it's passing. Wherever we are expecting false, it's passing. Wherever we are expecting true, it's failing. So it should pass for all, right? So what I'm going to do is I'm going to minimize this and we are going to start writing the solution. So in the first solution, what we are going to do is we are going to use a formula to get the reverse. And the formula that I'm going to use is, I can say a variable, so any variable equal to variable into 10 and going to add the remainder. So this is the formula that I'm going to use over here. You can even write the solution by getting the last digit, adding it to a string, and then essentially converting that string to an integer. You can even do that. But I'll go by this approach over here, right? So I'm going to create few variables over here. I'm going to create temp and I'm going to assign it the original number that we are passing over here. So this I'm doing is to preserve the number because we'll be modifying n. So we should store the original value of n so that we can compare it later on. So the reason we would be comparing is to check if it's palindrome or not, right? So we have created a variable temp and I'll also create a couple of more variables. I'll create a variable called remainder, which will store the remainder of that we calculate from the number. I'll create variable called sum, right? And now I'm going to run a while loop. I'm going to say while n is greater than 0. Okay, and say remainder. So I'll get the remainder first. I'll say n below, right? So this is the remainder that I have got. Now I'll use this formula over here. So we'll use the variable sum. So sum is equal to sum into 10. This around brackets. And I'll add number here. Add the remainder here. right? And I'll say n is equal to n by, right? So what we are doing over here is we are finding the reverse, and then after we get the remainder, we are reducing, or we are removing the last digit. Okay. Now what we need to do is, so we have reverse with this variable over here, sum, and we have the original number stored over here, temp. So n is modified because we have continuously divided n and we made it 0, right? But we have the original number that we received in temp. So what I'm going to do is I'm going to compare straight away. I'm going to say if temp is equal to sum, I'll say return true, and else we can return. I'll just delete this return statement. Now let's run the code and let's see what the solution looks like. So you can see we are getting past all the test cases essentially over here, right? So if you haven't understood this modulo operator, what I will do is I will write a print statement over here and I'll print remainder so that you get a clarity on what exactly is happening over here. I'll just run this and you can see we have some prints over here. So for 1 to 1, we first got 1. N divided by 10, right? We got 1. Then we are printing that 1 over here. Then in the next loop, we got 2, right? And in the next loop, we got 1 again. So 1 to 1, we got every single digit in every iteration of the loop. So that's the benefit of using the modulo operator. And I will also do another print over here, right? A n. I'll run this. So I'm just printing the value of n at that given point in time. So you can see in the first iteration of while loop, we got 1, and then we divided n by 10. And once we divided, 1 to 1 became 1 to. So we got 1 in the remainder, which is nothing but the last digit. And after getting the last digit, we removed the last digit by dividing the number by 10. Then the second iteration, we got the last digit. The last digit here was 2. And then we divided n by removing 2. Then we got the last digit as 1, and then n became 0 because we removed the last digit. And then we exited this loop because n is no longer greater than 0. And then we got the reverse simultaneously over here inside, and we compared it with the original number, and we got the output as true or false, whatever. So just by writing a couple of print statements, you get a clarity on what's happening exactly inside your code. So this is one way of solving the solution. Okay, I can see there are a couple of optimizations that are possible right now. So we are checking if temp is equal to sum, and then we are returning. So we can optimize this line and you can see if statement can be simplified. So IntelliJ is telling us, I'll say revert if statement. We don't want to revert. Is we are going to say return. So whatever is the output of the comparison is returned. So if they both are equal, true will be returned. If they both are not equal, false will be returned. We just saved a couple of lines of the code by optimizing this particular solution. So this simple optimization was possible here. So I thought I would do that. So this is one way of solving the problem. Okay, there is another way wherein you can even get the reverse by using string. So you get the remainder over here. Okay, now instead of using this formula here, you can create a string builder over here. So I can say, you get this entire code right over here. So sum, I'll say string builder. String builder. Instead of this line over here, I'm going to say append. We are just appending the digits that we are getting, right? And here I'm going to compare it with the answer. And Since temp is an integer, I need to parse it to the int. I'm going to say ans. Bring an error because you have to pass in string as the input. So I'll just cast this to string. I'll run this. So you will still get the same output here. Everything is passing. So what we did over here in this particular solution is we now using string builder, and we are getting the reverse using string. Instead of using this formula, we are now just appending in the string, and in the end we are just converting this string builder to string, then string to integer, and we are comparing and passing the output. So this is how you can solve this particular solution, guys, and I hope you guys now have clarity on what the solution looks like and how can you go about solving this particular problem. So I hope you guys enjoyed this class and found this class really valuable. I think we covered a lot in this lecture. So I hope you guys enjoyed this class. I'll see you guys soon. Thank you. Hello guys, welcome back. So in this lecture, we are going to solve another problem. And I have the problem open here in the coding editor. And I'm just going to go to view documentation here. So here's the problem. So we need to write a code to check if an electric car is ready to drive. And what do I mean by ready to drive is it's ready to drive if the car's battery is not drained and if the doors are locked. So we have to check if our car is ready to drive, and we'll do this check and we'll say it's ready to drive when the battery is not drained and the doors are locked. So we have to write a method which returns true if the car is ready to drive and false if it's not ready to drive. And we would be writing our code in this particular method here, ready to drive. And you can see it accepts two parameters. So the first parameter is the battery parameter. So first parameter says battery not drained, and the second parameter says whether the doors are locked or not. So if both are true, we return true. If the battery is not drained and if the doors are locked, then we return false. So you can see over here, this is the method we are talking about. So if the battery is not drained, so if this is true, and if the doors are locked, then our car is ready to drive. If the battery is not drained and if the doors are not locked, we get false. If the battery is drained, which means that battery not drained is coming as false, and the doors are locked, then also we get false because the car is not ready to drive. And if both are false, that means battery is drained, and if the doors are not locked, then we get false again. So we have to write the code over here. Okay. All right. So this is about the problem now. Now, what I would request you all is to pause this video right now and attempt this solution yourself and see if you can come up with a solution that satisfies these test cases, right? So pause the video right now and try attempting this problem, and I'll see you guys soon with the solution shortly. So welcome back. I hope you guys got a chance to attempt the solution. So I'm going to start writing the solution here. I'll just start by writing a couple of if conditions, or not couple, we'll actually need one if condition. So we need to see if the battery is not drained and if the doors are locked. And if both the conditions are satisfied, we return true, else we return false. So I'll start writing if battery not drained equal to false, or door locked equal to true, then I return true, and else I return, and I'll just remove this line over here. Pretty simple. I'll just run this code and let's see what the output looks like. So you can see it's passing for all the test cases over here, right? And this solution was just a if statement. So we checked if the battery is not drained and if the doors are locked. Okay, this solution worked perfectly fine. And I would like to highlight that there is a scope of optimization over here. So it's 4 lines of code. You can even optimize it. So the first optimization is we have to see whether this condition is evaluated to false always. So instead of comparing it with false, since it's already Boolean, so what I would do is that I would just remove this. I'll say not over here. So if this is true, and I'll just remove this part since it's already Boolean. So if this is true or this is true, then return true. Okay, I'll run this code. You can see. So false, false, get true, true, false, you get false. So you can see this solution works perfectly fine. So this is one way of optimizing it, and I can still see further scope of optimization. So this entire 4 line code can be trimmed to 1 line. There is no need to write 4 lines of code. And how can you do that? So I'll just delete this here and instead just pass return over here. You can simply return this. Let me run this code. Well, it works fine. So you can see how we optimize this from multi lines of code to a single line of code. So this is our solution. So we are checking if the battery is not drained and if the doors are locked, then our electric car is ready to drive. So let's summarize. So in this lecture, we understood this problem of electric car and checking whether it's ready to drive or not. And we saw different ways of solving it and optimizing it. So I hope you guys enjoyed this class and found it valuable. I shall see you guys soon. Thank you. Hello guys, welcome back. So in this lecture, we are going to talk about the spaceship problem. And by the end of this lecture, you are going to have a complete clarity on what this problem is. We will be understanding this problem and we will also be taking a look at the solution. So let's get started. So I have problem already open here on my coding editor, as you can see, and we'll go through the problem. So we need to write code to check if there is any issue with our spaceship. And our spaceship has two indicators. One is the red indicator and the other one is yellow indicator. The spaceship is having problem if both the indicators blink or none of the indicators blink. So either both should blink or none should blink. If one blinks, there is no problem in spaceship. Now we have to write a method that tells us if a spaceship is having any problem or not. And we return true if there is any problem and false if there is no problem. So here's the method that we are going to write, and you can see this method ready over here. And you have two parameters. One is for red indicator and one is for yellow indicator. So true indicates that red indicator is blinking and false indicates that this red indicator is not blinking. So it's same for yellow indicator as well. True and false, we'll have two parameters. So you can see the test cases over here. So you have true, true. So if both are blinking, so you return true because there is a problem with the spaceship. If one is blinking, then you return false because there's no problem with the spaceship. If yellow is blinking, then again there is no problem with the spaceship. If both are not blinking, then there's a problem with the spaceship. So any one of the indicators have to blink. If both are blinking or both are not blinking, then there's a problem. So this is the problem that we have to solve. Now, I would request you all to pause this video right now and attempt this solution so that you get some practice on logical thinking. So pause the video right now, attempt the solution. I'll see you guys soon with the solution. Thank you. So welcome back. I hope you guys tried attempting this solution. We will try attempting this solution ourselves. So we'll start by writing if conditions. So we have to check if the indicators are burning or not. We'll say if red indicator is true. So if red indicator is burning and if yellow indicator is also burning, So if both are burning, we return true. Else, we check for the second condition, else if. So if red indicator is not burning and yellow indicator is also not burning, then we return true again, or else we return false. So delete this code. So it's pretty simple. We check if both are burning or if both are not burning. And in both the cases, we return true, else we return false. Let's run this code and let's see what the output looks like. So you can see all the test cases are getting passed away, right? So this is the perfect solution. Now let's see if we can optimize this. So since the input is in Boolean, we can definitely remove this is equal to true. I'll just say simplify. And IntelliJ is smart enough to give all these tips to us. Simplifying, we are simplifying. By this, run this, you can still see the same output. Okay. Another way is you can convert this entire code a single line. How can you do that? So I'll just comment this here. I'll say return. I'll take this condition, okay, or take this condition. I'll put it over here. So I just converted this multi conditions into a single condition, and I've used this or operator over here, right? Now let me run this. Let me see the output. So you can see it's still passing. All right. Now OR operator will make sure that if either one is true, it will return true in that case. Okay. So if this particular condition is true, then it will return true. And if any of the conditions is true, you will get true as the output, else you get false as the output. All right. So this is one way of optimizing. There is, you can even optimize it further. You can see one pattern over here. So you get true if both are true, right? So this is a pattern, and you get false if they both are not equal to each other, I should say. So if these both parameters are different, then you get false. If they both the parameters are same, then you get true. What I can do is I can simply read this entire thing. I can say turn red indicator is yellow indicator. I'll return the output of the comparison for both. So if they both are equal to each other, you get true as the output. Okay. They both are equal to each other, you get true as the output. If they both are not equal to each other, you get false as the output. Simple. I'll run this code and it works perfectly fine. So this is how we optimize this particular code over here. And you can see we reduced this code from, I think, 1, 2, 5, 6 lines, a single line with just one comparison. And this is the most efficient solution for this particular problem with just one condition check. So let's summarize. So in this lecture, we understood how we can solve this spaceship problem. And we also understood the problem first. We tried attempting it ourselves and we saw the solution as well. In the end, we also optimized the solution by ourselves. So I hope you guys enjoyed this class and found this class valuable. I shall see you guys soon. Thank you. Hello guys, welcome back. So in this lecture, we would be talking about a problem wherein we will be checking the farthest number. And by the end of this lecture, you will have a clear understanding of this particular problem. And we will also be understanding its test cases. We will also be exploring the solution. And we'll see if we can optimize it as well. So I hope you guys are excited. So let's get started. So you can see the problem here on the screen. So problem is write a program which returns the farthest number from 20 out of all the numbers that are given as an input. And you can see the function is over here. So you have this function return farthest, which accepts two parameters, n1 and n2. And what you are essentially doing is you are checking which number is farthest of both these numbers from 20. And whichever is the farthest number, you are returning that number in the return statement. So if you see the test cases over here, you see the test cases. So if you are getting 12 and 9 as the input, you can see 9 is far away from 20 than 12. In case of this second test case, you can see there are two inputs, 22 and 23. So which one is far from number 20? So obviously 23 is far away from the number 22. In case of 33 and 100, you can see 100 is far away from 20 than 33. And in case of 1 and 0, 0 is far away from 20 than 1. So 1 is a little bit closer than 0 from number 20. So this is the output that we are expecting. So what I would expect right now is, since you guys have a clear understanding of the problem, I would request you all to pause this video right now and try the solution yourself. If you are able to solve the solution, well and good. If you are not, no issues. You can resume the video and take a look at the solution. So pause the video. I'll see you guys soon. So welcome back. I hope you guys got a chance to attempt the solution yourself. So we'll try solving the solution ourselves. So what we are going to do is we are going to start typing in the code. And let's think on how we can arrive at the solution. So we have to check which number is farthest from number 20. What we are going to do is, one way is to get the difference between 20 and that number and then comparing the difference. All right. So for this particular example over here, 20 minus 12 is 8 and 20 minus 9 is 11. So you got the difference of both these numbers from number 20. And now you see which one is greater. So over here, I can clearly see 11 is greater. So 11 is the difference of 9 from 20. And hence 9 is farthest. All right. So this is how we will be coming on to the solution. So another way, another parameters or another test case that we have is 22 and 23. So what is the difference of 22 from 20? So the difference is 2. And then we have 3 as the difference. And 3 is greater than 2. So if 3 is greater than 2, obviously 23 is farther. And likewise, we'll be doing for these two test cases as well. So the first step, like we know now over here, is getting the difference. So we have to get the difference of both the numbers. So first I'll start by getting the difference of the number n1. Then I'll get difference 2 of number. All right. So we are getting difference of both the numbers over here. After we get the difference, what we are going to do is we are going to compare the difference. If 1 is greater than if 2, then we return n1. If the first difference is greater, then n1 is farthest, else n2 is farthest. Right? And I'll just delete this return statement over here. And if we need to handle one more condition, if both are equal, then we return 0. Right? So there's one odd case that we need to handle. If 2 greater than if 1. Right? So we have written the code. Let's now run the code and let's see the solution. So you can see we are failing for these two test cases. All right, I know the reason as well. So problem is these two numbers, 22, 23, like these two test cases have numbers greater than 20. So our code is working well if the numbers that are passed are lesser than 20 because the result is positive. But if the number is greater than 20, you are getting a negative number and then the comparison is failing. All right. So in order to solve that, we need to use this function math.absolute, wherein we are converting a negative number into a positive one. We'll be using this particular function over here. Right. And now we'll run this particular code. Let's see what the output looks like. So you can see the output is perfect and it's working fine for all the test cases. So some couple of lines I would like to say about this function absolute. So without absolute, we are comparing the negative values and we are getting the wrong result. It would work fine if the numbers given as the input are smaller than 20. All right, without absolute, if the numbers given as an input are smaller than 20, then it would work absolutely fine. And to make our program robust, we need to make use of absolute function from the math class so that we can play with a wider range of value as an input. So I hope you guys got some good clarity on how you can solve this particular problem. So that's about this class, guys. Let's summarize. So in this lecture, we understood this problem, return the farthest number from 20, and we also understood its solution. So I hope you guys enjoyed this class and found this class super valuable. I shall see you guys soon. Thank you.